Welcome back to Science. Okay, so when we left off last time, I could ask you if you could label this periodic table. Up here, you can either label it or color it. So one of the things I wanted to point out is francium is considered the most reactive of the metals. We looked at the alkali metals and we saw how reactive francium was. It blew up, and it's also considered the most metallic metal. So as we go this way and down, the elements become more metallic. And then fluorine is the most reactive nonmetal up here in the other corner. So we know that noble gases don't react at all. So out of the stuff that reacts, the most reactive of the metals and the nonmetals are kind of like at opposite corners. They're opposite corners. They're both reactive. This is the most metallic. This is the most non-metallic, and they're both the most reactive. Then it said to color the noble gases red, and I'm putting the labels on as well. The alkali metals yellow. The metalloids are already along here, and they're orange. Halogens are green. Now notice that acetane is a metalloid, but it's also a halogen. Okay. The alkali metal is brown. We're going to circle hydrogen because it's a gas. Okay, now on this vocabulary review, and I know I've asked you to color the periodic table a bunch of times, but they want us to label this box. Top number is the atomic number, the symbol, the element name, and the average atomic mass. And it said label the periodic table. I made the alkali metals yellow. The halogens here are green, and there's like green lines to acetane, but it's also along here where the metalloids are. The noble gases are over here, they're red. The alkali earth metals are these ones that are blue. Transition elements are in here, I mean in this light purple color. The inner transition metals, sometimes they're also called rare earth, are down here. I made them these purple ones. Okay, and then circle the metals. Well, the metals are everything over here except for hydrogen, and the nonmetals are everything on the right-hand side, and then just don't forget about hydrogen over there. It's gas. Okay, on this vocabulary review, we're going to go through the basic vocabulary of the unit. The atomic number equals the number of protons in the nucleus. And we're not maybe necessarily writing in full sentences or a big description. These are the important things that you need to remember. So this would be a real good page of study. Atomic mass is the sum of the protons and neutrons in the nucleus. Chemical symbol or element symbol. There's one or two letters that represent the element's name. Protons are located in the nucleus and have a positive charge. Neutrons are also located in the nucleus, and remember neutrons, and they have no charge. The nucleus that we built with all the Bohr models is in the center of the atom. It contains the protons and neutrons. Most of the mass of the atom is in the nucleus. Remember, electrons really don't have a mass. They're not included in the atomic mass. Electrons are equal in number to protons because the atom is neutral. They're located around the nucleus. Valence electrons on the outermost energy level, and they're the ones that are involved in bonding. The electron cloud predicts the location of an electron. Electron cloud is the most modern representation of the atom. Remember, in class we use the Bohr model because it's flat and it's easy to draw. And it shows also the electrons in energy levels, so it gives us an accurate picture that we can visualize of what's going on. It's just not in a cloud three-dimensional. The periodic table that we've been studying is organized left to right by increasing atomic number, and it's organized by repeating patterns of families. So families have the same number of valence electrons, and the periods across have the same number of energy levels. Which brings us to groups of families. They're the vertical columns on the periodic table. The The groups are organized by valence electrons, and we've labeled families 1, 2, 3, which sometimes says 13, 4, 5, 6, 7, and 8. Periods are the horizontal rows on the periodic table. Periods correspond to the energy levels in the atom's model. So remember, we said the periodic table is organized by the way nature is, by valence electrons and by energy levels. Metals are located to the left of the staircase, or the zigzag, with the exception of hydrogen. They're malleable, ductile, shiny. They conduct heat and electricity. Nonmetals are to the right of the staircase in families 5, 6, 7, and 8 valence electrons. Their properties are the opposite of metals. They don't conduct, they are not malleable, they are not ductile or shiny. They're considered brittle, and then fluorine is the most reactive nonmetal. The metalloids are kind of in between. They're located along the staircase. Their most important property for the 21st century is they're semiconductors, and they have properties that are in between metals and nonmetals. The alkali metals are in family 1, and they have 1 valence electron. They're the most reactive of the metals. Took a look at that on Brainiacs and those other videos I showed you. The Alkali Earth Metals are in family 2. They have 2 valence electrons, and they're the next most reactive. So if we look at them, like, calcium is in milk, is in bones. We don't find that, in pure in nature. It's because they're reactive. Halogens in family 7 or 17. They have 7 valence electrons. They're the most reactive of the nonmetals. Fluorine is the most reactive halogen. It's also considered the strongest nonmetal, like we looked at that periodic table before. Noble gases are in family 8 or 18. They have 8 valence electrons, except helium, which has 2. They're stable, and they don't react. Transition elements are in families 3 to 12 in the middle of the periodic table. They usually have 2 or 3 valence electrons because they transition from being like family 2 to being like family 3. They're often very similar properties, and they're hard to tell apart. These are the things that we typically think of as being like, metal. So, you see things like silver is silver, and nickel is silver, and, they're shiny, and they conduct electricity, and so that's what it means when they have similar properties, and hard to tell apart. And these are the metals that we think of when we think of metals. Okay, so like alkali metals, those are highly reactive. We don't see them in nature, so you really, you don't think of them as being metals. Same thing with alkali earth metals. So it's these ones in the middle that, when we think of like chrome being a metal and iron being a metal, those are the ones that we're familiar with. Titanium, like they make baseball bats out of sometimes. So that wraps it up for this unit, and good luck on the test, and we'll see you next time.